Hey everyone, this is a quick look at the answer key to the practice test that is posted. Try to get through this pretty quickly. This picture here is just a way of visually representing what we do when we multiply something like a binomial times another binomial, and you write it as this: 2x plus 3 and 2x plus 1, and we're making a rectangle, so the area is then the product of those two. And so when we FOIL them out, we get the correct answer by grouping similar terms with the O and the I part. The F part will produce an x squared term. The L part, the last terms, will produce a number. You'll see this pattern is very familiar, but you can also think of it as individual units, and each of these x by x will give you x squared, and if you tally these up, it'll be the same thing. So this is what this problem is all about, just showing that there's a way to visualize what's going on and making sure you understand why it is what it is, not just memorizing the FOIL part. Beginners, when they do this, often only multiply the x's and only multiply the numbers. That's why you'll see that when you have something like x plus 2 squared, it's not just x squared and 2 squared. You have to get the outside and the inside. You have to FOIL it out to get the correct answer. So if you see this on a test or a quiz, don't fall for just bringing that square in. Make sure you write two of them side by side, x plus 2 times x plus 2, and then FOIL it out. All right, we might see that below. All right, here is scientific notation, pretty straightforward. Count up the zeros. Scientific notation always has a number, single digit with a decimal point, and then another digit. You can have more significant figures, they're called. You can have more degree of accuracy with more decimal places, but usually when you're dealing with big numbers, it's impossible to be super accurate and perfect, so we just don't worry about that. And so you'll see very commonly scientific notation is like this. If you multiply numbers with scientific notation, remember it's all multiplication, so we can group things the way we want to. That's what's going on down here. We're taking this number and then this number, and we're grouping the first parts right here and multiplying them to get 11.59. Then we're grouping these parts where we just add the exponents. 27 and 23 make 50, but 11.59 becomes 1.159 when we move the decimal place this way to make it 10 times smaller. We add another 0 and make it 10 times bigger, and that stays balanced. So this would be the correct way to write that. This is still correct written down here, 11.59 to the 50th, but this is the best way of doing it. Okay, breaking down 540 into prime factors. Always take out the smallest number first. I'm not doing this down, there's not enough room. I'm sort of doing it sideways, but you get the hockey stick going this way and writing it as prime factors with exponents. That's a fancy way to do it. Make sure you understand that skill. Then these, here's a chance just to practice a bunch of these, make this muscle memory. Whenever you see them side by side, just make it reflex that you add them. Whenever you see them grouped with parentheses, make sure you multiply them. That's on the next page. So all of these are very repetitious. They're just adding exponents. Now the opposite is true down here. When they're dividing, you subtract 9 minus 4. Think of it as 3 times 3 times 3, 9 of them, over 4 3s. Well, the 3s that are above and below each other will cancel out. So 4 of these cancel with 4 of those, leaving you only 5. Same thing here. Pretty straightforward. All right, moving right along. Same type of thing, working with rules. We're just dividing, getting more practice. Very straightforward. Here again, we're just adding. Here again, we're just adding. The trick to remember with 5s is you don't multiply the 5s. That just establishes the basis. And so this is 1 5 and 3 5s and 11 5s. That's a total of 15 5s. These 5s don't magically multiply to become 25 to the 15th. Avoid that mistake, please. All right, so now here's working with exponents of exponents. That's when you multiply. You do bring this in and multiply it. That's x to the 8th and y to the 12th. You can see that. You can expand it, show that you know that the 4th power of something just means that something times itself 4 times, and you're good to go. All right, so this one looks familiar from a previous quiz. Same thing here. Down here, you're going to make sure that you bring this 2 in. 3 squared is 9. That is not a 6. That is 3 to the second power, which is 9. 9 over 9, poof, that's 1. 3x's over 2x's cancel out and you get 1. 5y's over 4y's cancel, you get 1. A very simple answer right there. All right? And so now this last bit is all about foiling. Just go very carefully, term by term. Don't make any mistakes by like multiplying x times x and getting x. It's always going to give you x squared, that first term. So you start to look for the pattern. You get a squared term at the beginning, you get a number at the end, and you have 2 middle bits that are x's that you combine, in this case 5x. So each of these is being foiled very carefully. Here's one of those ones that I told you is squared. You do not just bring the 2 into each of these and leave it. You have to foil it out. All right. So all this work is pretty straightforward. Again, here's one of the fractions. You just want to go very carefully. 5 over 2 times 7 over 2. You multiply the 2's and get 4. You multiply the 5 and the 7 and you get 35. You do that very carefully for the outside and the inside, and then the last bits. Keep track of all your fractions and you will get the right answer. You can use your calculator to help with the fractions at times. Just keep track of everything. All right. Then we've got a couple of word problems. This one is just working with big numbers, scientific notation numbers. They tell you that the distance r that goes into this formula, m over r squared, is that r is this, this amount right here. And I think looking at this, maybe I made a mistake. I believe this should have been squared. Okay, so the answer key has a little mistake in it. See if you can correct that. That becomes 2 times 10 to the 4th squared. So this actually would be 2 squared is 4. 10 to the 4th raised to the 2. Remember, we multiply that times 10 to the 8th. And then that means that when you divide this by not 2, you divide it by 4. So it would be half of this. Half of 99.8 is going to be 49.9. And then you would just have that be, instead of to the 4th, that's to the 8th. So this would lose 4 more zeros, and this would be 10 to the 6th. Okay, so that is how you need to divide this by 2. 49.8? 49.8 times 10 to the 6th. Okay, so check that. Maybe you got it right. This one is a little bit more standard, like what we've done in class before with these variations. This one is a cubic variation, so you know you want to start off with your basic equation like that the energy you get is based on the cube of the depth of the water. Fill in your numbers. Don't get psyched out by scientific notation. You can handle it. Use your calculator. Turns out it's going to be 8,000 divided into 2.7 times 10 to the 8th. There's your K value. You plug that back into your equation like I've done right there, and you put in your new depth, and you'll get your new energy amount coming out. In this case, you'll see it goes from 2.7 to 9.11. The depth only goes from 20 to 30, so it's nowhere near doubling, but the power you get coming out way more than doubles. It's more than 3 times as much. That's because the cubic relationship makes something grow really quickly. Working backwards from a known power, you divide by your K value, and then you have to know how to take the cube root of that number. So you go to your calculator, you do math, you select cube root, and you type in 1392.59, hit cube root, and you're going to get around 11.17 meters. Okay, there you go. Kept that key under 10 minutes. Good luck, everybody.